Hi, everybody. Today we're going to be taking a look at 6.6, proving triangles congruent, AAS, ASA, and HL. So let's take a look. Okay. So angle side angle congruence postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So we're going to draw two triangles here. Okay. Oof. Yellow's kind of hard to see, huh? All right. I'm going to try to realize the best I can the same. There's one, there's one. So one's going to be called ABC. I do apologize, I'm writing with my mouse right now. So if it looks terrible, we're going to go with that. And DEF. All right. If A is congruent to D, okay, AC is congruent to DF, and C is congruent to F, then you have ASA, all right, angle, side, angle. So this is much the same as we did the past week with, SSS and SAS. Instead of tick marks now on the outside, we're referring to our curve on the inside. So you're looking for them in succession, angle, side, angle, okay? You wouldn't want to say SAA because that's skipping too many sides, right? Very cool. Okay, so I'm going to go down here, okay, and then I'm going to, ooh, lucky me. Look at that, that's awesome. Yeah, go me. All right, now AAS, congruence postulate, okay? If two angles in the non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So not a really big swing here, but instead, this is saying if angle A is congruent to angle D, angle C is congruent to angle F, which is the same thing we had in the last one. But notice here, they're telling you BC is congruent to EF. So here's the thing, and just to slow it down a second, now we're saying the congruent side is not included between the angles, but on the outside of it. So it goes angle, angle, side, AAS. That's all right? So it's all about patterns. I know this is confusing because you might be going, what about angle, side, angle? But if you do that, you're skipping this side, you're skipping that angle. You can't skip, okay? Very cool. So there's my ASA, my AAS, and then lastly we have HL congruence theorem. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. This is a weird one. Here's why. It's technically our ASS, which you can't have that, right? Angle, side, side. That's the bad one, right? But it works because I have a right triangle. When you hear HL, that means you must have a right triangle. Must have a right triangle. All right, must have a right triangle. Sweet. Good stuff. All right, cool. So here we go. We're going to take a look at all these now and see how it goes. Determine whether enough information is given to prove the true triangle is congruent. So we're looking for our constant things here. These triangles are back to back. I've got this angles the same. So the side that they're touching can be the same as well. So we've got an angle, we've got a side, we've got an angle. A, S, A, postulate. Cool. And you don't have to write down the word postulate, but I'm just doing it for that first one. Great stuff. All right, for part B, you'll notice that I've got an angle and a side, and they're right here in the middle across from each other. These are vertical angles. Okay, so we can say that they're congruent. So again, we have another example of A, S, A. But notice here how it's different compared to that one, right? You can go about it a different way. All is well. Okay. On the back, just a bunch more. Now here we have an angle and we have a side, but notice that's all we have is an angle and a side, nothing else. There's not connecting, there's no vertical angles, there's no reflexive, there's no parallel lines. So this is what we would call NEI. That is not enough info. All right, we do not have enough to help us out there. Okay. Part D, yes, these are back to back. All right, so you can say they're the same. Great. But again, look what we have. We have a right angle, so we're thinking maybe hypotenuse leg, the thing we just talked about. But even with hypotenuse leg, you have to have an angle and you have to have two sides. I only have one here. So it's okay to get NEI, So please do me a favor and don't get trigger happy with this. Okay, what tends to happen is kids just start putting down NEI for everything if they're not sure. That's not normally the case. Okay, NEI just means not enough info. Down here, again, hey, look what we're looking for. They're across from each other. Anytime you see that crisscross going, we can say that these angles are going to be the same. We can say that by vertical angles. Okay. Okay, good news. Now, if you look at this top triangle only, I've got an angle. I've got a side. I've got an angle. Okay, angle, side, angle. I'm trying to go in succession. A, S, A. Very nice. Part F, again, they're back to back. Okay, back to back. That means that these sides here in the middle are going to be the same. Hopefully, you guys are starting to slowly notice that there's more and more of just, hey, what you see common. Angle, side, angle. Okay, A, S, A. And again, it's recognizing patterns is all we're doing so far. Okay, very cool. Yeah, there. All right, then down here. Now be careful on this one. This is a very tricky one, and don't expect to see much like this. But if you look at the left one, we've got a side, angle, side, which is great. But notice how this picture is not the same. This goes side, angle, and it skips a side. Not the same. Okay, so anytime you see something like that where the pictures clearly aren't the same, right away you can say A-N-E-I, not enough info. Okay, as I just finished telling you that there's not a lot of NEIs, and we got 3 of them in a row. So all good. You're just looking for the patterns. Okay. Finally, this last part, guys. All right, it just says state which additional information is required in order to know the triangles are congruent for the given reasons. So they want you to prove this is ASA. Okay. Well, this is ASA, so you're drawing in what you need. I've got an angle on both triangles. I've got the side that's the same that's connected right here. Oof, that's a terrible tick mark, sorry. Okay, AS, that means this angle has got to be the same. Okay, all right, so you have to say like angle DUT. DUT is the same, is congruent as angle TUS. Okay, very nice. HL, okay, hypotenuse leg. You've got a right triangle. You can see that these are back to back, which is all well and good. So there's your leg. Okay, that's the leg of the right triangle. And the hypotenuse would be over here. Okay. So once you draw those in there, you're good. I mean, if you didn't want to draw them, you could say that XV is congruent to XV. You could also see that WX is congruent to KV. Okay, all good there. Finally, for angle, angle, side, you've already got the angle. Okay, you've already got the other angle, angle, angle. Right, now here's where it gets a little bit tricky. So I'm going to put the side next to the 1 dash. Okay, I'm going to put the side next to the 1 dash, right? Or the 1 curve, we can say. So that means I got to do the same thing here. I wouldn't want to put it there. I want to put it next to the 1 curve, the 1 curve. And then we're all good. You can say here again, DF is congruent to JL. Okay, good stuff. All right. Awesome. So good stuff, guys. Okay, pretty simple. Again, we're just adding to our toolbox. We have ASA, AAS, and HL. I hope that helps. As always, keep up the good work and good luck. We're all counting on you.